Welcome to the second video in our series showing you how to reduce ARCoIRIS data. In the first video we went over setup for the package and how to do calibrations, and in this video I'm going to show you how to extract your spectra and how to combine them together. Okay, so the first thing we're going to want to do is start up IDL, open up Spextool with the command Spextool. You'll notice that it's saved the paths that we had from the previous video, so that's very handy. And what we're going to do is move for extraction over to this point source tab. So as an example here, I'm going to show you an extraction of a telluric standard. So what I can do here is put in my numbers. I want to put in my first AB pair. So for this object, that was 309 to 310. I want to put in the flat that we created in the first video, as well as the wave cal. And then I need to make sure my input prefix here agrees with what is in the raw data directory for these file numbers, which is spec_obj. And once I have all of that set, I can go on ahead and load the image. Okay, so this shows the A minus B image, and you can see that this is a very well detected source, as it should be, given that it's a telluric standard. Okay, so what we're going to want to do next is for each individual order, we're going to want to collapse the data in the wavelength direction so that we see where we want to extract the spectra in the spatial dimension. So to do that, what we do is we go to step 1 here and we just click on Make Spatial Profiles. Okay, so this now shows the profile for each individual order. So it looks very good. The seeing on this night was quite nice. Okay, so now that we have that done, what we're going to want to do is find the center of our extraction aperture. So find the center of where we're going to be extracting the spectrum. And to do that, you have a couple of options here. The first is this auto button, which is the easiest, and if you have bright objects, that almost always works. So if you have that, you hit Find Store App Positions, and you can see that it found the center of the trace for each order. Okay. Another option, say sometimes when you're dealing with faint objects, you'll wind up having, it will wind up finding not the right peak. And if that winds up happening, there's a couple of different options here. You can choose Guess. So in this case, you know, if I wanted to put in a guess of 7 and 20, that should get me to close to the right aperture. So I could do 7 and 20, and that works pretty well. Another thing that you can do is you can fix it. Now if you fix it, it's the same value across all of the different orders. But say that I knew that I wanted to extract at 6.9, and you can use the red cursor over here, and the cursor X up here shows you what the value is. So I could put in 19.85 and 6.8. And I could put those in here with fix, and then it would just be extracting along that being the middle of the trace. Okay, but we're going to use auto because that works great in most cases. And there we go. I should mention that another option that you have here is sometimes you'll wind up having a fainter object that fell in the slit. And that can be tricky to try and reduce around. So one of the things that you can do is you can actually up your number of apertures here to 4. So say that you had, something that landed on the slit and you wind up having a third aperture, you can actually extract it, and what that does is that later in the process it will account for that aperture when it's doing the background calculations. Okay, but for now we don't have anything in here. This one looks awesome. We have found the center of the trace for all of our orders, and now we can choose the orders that we want to extract. So if I had, for example, a very red object that maybe did not have good signal to noise or what didn't have a good trace in the shorter wavelength orders, I can unclick those and it will only be extracting the other ones. Okay, but this one looks great. The one thing that I will mention is that for telluric standards, For the telluric correction process, which we'll discuss in video 3, you need to make sure that you extract order 6. So you can do 3 to 6, just make sure that you always, for your telluric spectrum, have order 6 because it makes things much easier. Okay, so now we're going to go on and trace them. I'm just going to hit this trace button. All right, so it traced it, found where the object was in both the A and the B image in each order. Okay, so the trace looks great. Now, if for some reason, say again, you're looking at a faint object and your trace went awry in one of the cases, what you could do is click on this Use App Positions. If you click on that, what it does is it actually just uses the center that you picked here in part 1. That's all that it picked. So it only would just go with the app position that you choose there. It wouldn't actually correct the trace. But our trace there looks nice, so now we can move into defining the extraction parameters. So on ARCoIRIS, we do not have the ability to do optimal extraction, so what we're doing is aperture extraction. So what that means is this PSF parameter here, it doesn't mean anything for our extraction of ARCoIRIS data. The app radius tells us the aperture that we're going to be extracting. And then you can also set the parameters for the background. So these are the defaults, which for a lot of nights are going to be just fine. So let's go ahead and show what these look like. And they show up on both the image as well as our spatial profiles here. So the sections here that are in red are areas that are background, and so they're going to be fit as the background and they will be subtracted as we go through. So again, we're talking spatial dimension here. The green is going to be the aperture that winds up actually getting extracted. Now, generally speaking, you're going to wind up getting the best signal to noise if the aperture that you're using here, if it's maybe just a little bit more than the full width half max, that actually winds up being the optimum, where you have high enough signal noise, you're not including additional noise by adding pixels that don't have a lot of flux, but then you're getting most of the flux of the object. So that's what we found works the best. If you're happy with what you see here, you can go on ahead and click Extract Spectra. If you're not, what you can do is go through and change your parameters, and if you change them and then click Show Apertures again, it will update in this Plot Spatial Profiles the changes that you made. So again, you just kind of want the red to not have any object flux in it, and you want the green to get most of the object's flux. So it's good. So that looks good. I'm going to go ahead and hit Extract Spectra, and this actually takes a second, so we'll go on ahead and do that. As that happens, I'll mention a couple of other things that you can see on this Spextool that are options for your extraction. One is you might have seen that there were tabs for extended source and tabs for combined images. So those are options for different ways for you to do extractions. The extended source tab, you can actually go in and select different positions along the slit that will wind up getting extracted in different sections for background. So that's really handy, and that's this one right here, the extended source tab. So you can stick in your aperture positions, and then you can put in your sky and your apertures. So that one works pretty well if you're doing extended sources. If you're dealing with data that's really, really faint, you can combine the images together before you do the extraction. And that's what you can do on this particular tab. And I'd encourage you for both the combined images and the extended source tab to check out the Spextool manual, as there's additional pointers there. Okay, but for most of us, the point source tab is where the action is. So we just extracted this. It comes up in XVSpec. XVSpec, it shows now the extracted spectrum of our telluric standard, which looks pretty good. You can see that there's some little noise spikes in there as expected with an aperture extraction. But yeah, overall this looks really good. Looks good. Okay, so now we would want to go on ahead and continue this process for the rest of our data and for our science target. Now, there is something that can make your life a little bit easier. If you find that you're happy with the extraction that you got, and there's no question that you'll be able to use the auto finding and using the standard trace, if you kind of want the same extraction for all of the data within your set, you can actually change and put in the rest of the numbers in here. So let's do 311 to 316, the remaining frames for our telluric standard. And so if we have all of those, what we can do is we can hit this do all steps button. And if you do that, it will actually go through and do all of the steps that you need to reduce your data. So I'm going to go ahead and hit that. And then we will move on to doing the combination. I would also extract my science target here as well, using the same process. Okay,